In this video, we're going to take a look at factoring trinomials. We're going to be finding the X intercepts, which are also known as the roots of the function, or you could say the zeros of the function. We call it the zeros of the function because the X intercepts are where y is equal to 0. Whenever you have y is equal to 0, you have an X intercept. So 3, 0, negative 1, 0, 1.50. Those are all examples of X intercepts because y is equal to 0. Let's look at our first example. Before you start writing out factors of the first term and that last term, what you want to do is you want to see if there's any common factor that you can pull out. You also want to make sure that a is positive. So first of all, a in this case is positive 2, so we don't have to worry about a being negative. And then 2 and 13 and 15 have no factors in common. We can't factor out a common factor out of those. So now what we can do is we can factor the coefficient of the first term, of the x squared term, and then we can also factor the we can also factor the constant term c. So I write 1 and 15, and then 2 and nothing, 3 and 5, 4 and nothing, 5 and 3. We're back to 5 and 3. So those are my options. What I need to do is multiply 2 by either 1 or 15, and then multiply 1 by 15 or 1, and then think about what I can do to get 13. I have to add them because this symbol at the end is an addition symbol, so that means I add the products. So let's try one. Let's try 2 times 1, we'll get 2. 1 times 15, we get 15. And we add them, like we're told to with the products, we get 17, which is not equal to 13. So that's not going to work. So let's try again. What if we took 2 and multiplied it by 5? We would get 10. 1, we multiplied it by 3, we get 3. And then those products, 3 and 10, we're supposed to add them, again, because of this symbol. It tells us that we add those products. And we get 13. It wouldn't matter here if we got a positive 13 or a negative 13. We're not concerned with that right now. We just want to make sure that we got the absolute value of 13. So we got 13. So we know that we have the correct factors. So now what we're going to do is we're going to place our factors. And again, this is set equal to 0 because when y equals 0, that's how we find our x-intercepts. Our roots are zeros of the function. So this is a 2, so we have a 2x. We also have a 1x. Well, the 2x is multiplied by the 5. So we're going to draw what we call our rainbow. The 1x is being multiplied by the 3. So the 1x is being multiplied by the 3. So it needs to go in that position. And then this symbol, it tells us something else. It also tells us that both symbols will be the same, and they're both going to be whatever this symbol is. So they're both going to be an addition sign. From here, we look at the zero product rule. If this binomial is equal to 0, 0 times whatever x plus 5 comes out to will give us 0. Because when you multiply 0 times any number, it's going to give you 0. Also, if we get x plus 5 equal to 0, well, 0 times anything over here will also give us 0. So we have two different options. We could say that x plus 5 would equal 0, and we'll get a result of 0. Or we can make 2x plus 3 equal to 0, and we will get 0 in the end. Let's go ahead and solve for our x-intercepts. So we get 2x equals negative 3. I divide each side by 2. And one of the x-intercepts is negative 1.5. So negative 3/2, 0. x plus 5 equals 0. All right, so I'm going to solve this equation. We subtract 5 from each side and we get x equals negative 5. So the other x-intercept is negative 5, 0. If you would graph this on a calculator, if you type in 2x squared plus 13x plus 15, you would see that our quadratic would cross at negative 1.50 and negative 5, 0. Let's just check our work, and we're going to start by plugging in negative 5 into the original equation. So, I mean in this portion right here. So 2x plus 3 times x plus 5. What we're going to do is instead of x, we're going to plug in negative 5. Instead of x over here, we'll plug in negative 5. Well, 2 times negative 5 is negative 10. Negative 10 plus this 3 will give us negative 7. Over here, negative 5 plus 5 is 0. 0 times negative 7 gives us 0. So the negative 5 worked. It made y equal to 0. Now let me rewrite the equation. So we had 2x plus 3. 2x plus 3 times x plus 5 was equal to 0. Now instead of x, I'm going to plug in negative 3 halves. And it should come out to 0. The 2's cancel. 2 divided by 2 is 1, 2 divided by 2 is 1, and we get negative 3 over 1, which equals negative 3. And negative 3 plus 3 is equal to 0. And I'll simplify this other portion. 5 minus 1.5 gives us 3.5. And 0 times 3.5 does give us 0. So both an x value of negative 3 have 0, and an x value of negative 5 yields a y value of 0. So those are x-intercepts. Let's look at the next problem. Letter B, 3y squared minus 10y plus 3. You first check and make sure that a is positive, and it is. A is equal to 3. 3, negative 10, and 3 have no factors in common, so we're not going to pull anything out. We're going to go ahead and factor 3. Once again, we're going to add our products. 3 times 3 we get 9, 1 times 1 we get 1, and we get 10. So we have 3y, and we have y, and we know that the 3y was multiplied by the 3, and the 1y was multiplied by 1, and we know that the 9y should be negative, and that the negative 1y, or the 1y should also be negative, and that's because when it's a positive sign here, this also means that both symbols are whatever symbol is in front. So both of these should be subtraction. So we have 3y minus 1 times y minus 3 is equal to 0. So we can set each equal to 0. So one option is 3y minus 1 could equal 0. The other option is that y minus 3 could be equal to 0. So the variable that was used was y. We could have put anything in here. We could have also used r or t or m or z. But our two x-intercepts are now 1/3, 0, and 3, 0, because the x values are 1/3 and 3, and then the y value was equal to 0. So those are x-intercepts, our roots, our zeros of the function. Next problem. We're supposed to find the x-intercepts. So to do that, y has to equal 0. So I plug in 0. I wrote it as if I was plugging in 0 for x. I meant to replace the whole f of x with 0. So we set y as 0, and then we're going to factor the 4. So 4 can be written as 4 times 1. It can be written as 2 times 2. 6 can be written as 1 times 6, or as 3 times 2. And then again, we have to find the products, and this time we find the difference between the products to get the number 5. So let's just try some different examples to see if we can get the 5. For example, what if we did 4 times 6, or 4 times 2, and we got 8. 1 times 3, we get 3, and we get a negative 5. So first try, we happened to get that one right, but you could have tried a few different examples. So we know that our factors, we used our 4 and 1, so I'm going to put a 4t over here, and then I'm going to put a 1t in the other set of parentheses, and again this is equal to 0. And then the t was multiplied by the 3, and the 4 was multiplied by the 2. And then this symbol up here also means if it's a negative symbol, it means that one is positive and one is negative. So the signs are different. So this is 3t. 4t times 2 gives us 8t. And we know it's a positive 5t, so I want to have more positives than negatives. So I have negative 3t, positive 8t. So I make the 2 here positive, I make the 3 negative, so that when you take negative 3 and multiply it by t, you'll get negative 3t. When you take positive 14 and multiply it by positive 2, you get positive 8t. From here, we set 4t minus 3 equal to 0. We set t plus 2 equal to 0. We add 3 to both sides, and we get 4t equals 3. Divide each side by 4, and we get t equals 3/4. Over here, we subtract 2 from each side, and we get t equals negative 2. So our two x-intercepts are 3/4, 0, and negative 2, 0.